This is 3-1 instantaneous, average velocity, instantaneous velocity, and acceleration. And for this section, just do the entire worksheet on acceleration. Now, I've already mentioned this in a past lesson in class, and it was in the last chapter a little bit, an intro to it, but I'll bring it up again in 3-1. What do we mean by instantaneous or average velocity? Oh, sorry about that. Okay, here's a good little example. So let's just say that 10, 20, 30, 40, 50. Say that there are 50 yards, half the football field, and somebody gets up there to run. They start running, get all the way to here, like a race or whatever it might be. And let's just say it takes them 10 seconds to run that. Okay? 10 seconds to run that. Now, what that would mean is that would actually be kind of long. That could take a while. You could do better than that. But anyway, 50 yards in 10 seconds. We know that your velocity, now average velocity has a line above it like this. Your velocity would be equal to, we always talked about displacement divided by the change in time. The change in displacement or change in time. Now, so the change in displacement, the change in position or the change in time. Change in position or change in time, which is displacement. So displacement is usually written as a positive x. Positive x. We'll assume this is the positive direction, and of course that will be negative. One thing you'll love about this chapter is it's all going to be positive or negative. No more of the southwest, northwest, and all that stuff. Well, it might pop up once or twice. But anyway, so what you do, we went 50 yards. And so that 50 means positive 50. Now, if I put negative 50, that will mean they ran the other way. Okay, so 50 yards, and now the time, it will be the final minus the initial time. Now, we hardly ever write it that way because when you have a stopwatch and somebody's running, it starts on 0, okay? But if it didn't, because, sometimes you have relay races and you can, multiple stopping and starting times, you got to know what was your initial and your final time. So 50 yards divided by your final time, it was 10 seconds. 10 seconds. I'll put minus. The initial was 0, times 0. Okay? So 50 divided by 10 is equal to 5 yards per second. Actually, sig figs 5.0. If I counted the 0, I didn't mention about if these would be sig figs or not. But 5. We'll just say 5 for now. I didn't put that in there. 50 would just have one sig fig as it's written. So 5 yards per second. And that means the velocity is positive 5 yards per second. Okay, so here's the deal. So you ran 50 yards, it took 10 seconds. Was that person running, were they always going 5 yards per second the entire time? Every moment of time, were they going 5 yards? No, there might have been some changes in there. It might not have been level. Their footing might have been, they might have been increasing in some part. Like if they're racing, they weren't trying to run at constant time. So anyway, so here, what it tells you is the average. It means every little small moment along the way. That's called the instantaneous velocity. Kind of like when you're in a car, if you're driving, you look at what the speedometer says. And even on a bicycle, try that. Try to go on a bicycle. If you have that, you can get an app that'll do it. And try to go exactly constant speed. It's nearly impossible. You'll go up a little bit, down a little bit. Up, it'll go up or down. It might be 5 here. It might be 4.9 here. It might be 5.1 here. It might be 4.5 here. Then it might be 5.5 here. Then 5.2 here, and it might have been 5. So anyway, the truth is this: if you could add up all of the instantaneous velocities, like every moment, just say if you took one every 100th of a second. If you added all those up and divide by the total number of things, in other words, if you average them, you'll get 5 yards per second. So average velocity tells us the total distance divided by the displacement divided by the time. It tells you what was the average velocity. Now, instantaneous would be at any given moment along the way. So if you're not going at a constant speed, what is happening? You are accelerating. And on the paper, there's a word, where did we talk about acceleration? Let me check. I did not. How strange. I did not put that in there. I guess I put it on the next page, or it needs to be in there. Oh no, there it is. I see the equation. I didn't actually put the definition for it. But acceleration is change in velocity over change in time. So acceleration would be the change in velocity divided by the change in time. So if your velocity, like for example, well, let me do this in a way. I'm going to do it kind of like it is on your worksheet. But here we're running. So here's a 0. Here's I made it 10, 20, 30, 40, 50. Now, on the field, it's every 5 yards. So there'll be a 5 yard in between there as well. So let's just say, obviously, you're going 0 meter per second. What was your instant velocity at this? It was 0. At 10, let's just say that you were going at, you were up to, just say you were at 6 meters per second there, okay? At 10, I didn't put the time. I put 10 yards. So let's put the time in there as well. So let's just say that's 0 seconds. 0 seconds. Just say 1 second. Just say that was 2.3 seconds. Just say that was 4.7. I'm going to run out of numbers of 10. I'm not going to get 10. Well, maybe this will become a new example. 2.3, 4.7. I'll put 6.8 right there. So here's your time in seconds. And down here we'll put your velocity, your instantaneous. So instantaneous velocity would be like V. Average velocity would be like V with a line over it, meaning average. Okay, so 0, 6, then let's just say that here you were 4 meter per second. And here let's just say that you were 5 meter per second. And here let's just say that it was 5.2 meter per second. So it might be a little different than the velocity you had there. Okay, so let's just do this. Let's calculate, and I think you'll find this assignment to be pretty easy as well. You're going to see a little worksheet with the man driving on a unfinished freeway, and he drives by these little posts of a bridge, I guess, and it tells you each one how much time it took when they got there, and it tells the velocity that he had at each one. Like if you're doing this as well in the car, you write down, okay, what's the instant velocity now? Okay, when I pass this mile marker, or this mile marker, this mile marker. But we won't be mile markers, it'd be more like every few feet. Okay, so here we go. So calculate, not with the orange. Calculate acceleration. Acceleration between we'll just say 10 and 20. 10 yard and 20 yard. Now we don't use yards in this class, but we are right now. Between 10 and 20, what was the acceleration? Okay? So here's what you do. Acceleration is equal to the change in velocity over the I put an X. Change in velocity over change in time. That's your average acceleration. So that means V final minus V initial divided by time final minus time initial. So on this assignment, you are going to use a different, your initial time might not be 0. Now if I said between the 0 and the I said between 10 and 20. I just made this problem up. Okay, between 10 and 20, what was your velocity? What was your acceleration? So 10 and 20. Now final would be at the 20, between 10 to 20. So 20 would be your final. So at 20, the velocity was 4 meters per second. Minus, at 10, it was 6 meters per second. Your final time to get to 20, we said it took you 2.3 seconds. Now I just made this problem up here on the top board there, okay? 2.3 seconds, S, minus, and then your initial was 1 second. It said you got there at 1 second. I put 1.0 there. Okay, 1.0 seconds. Okay, so now, notice if I take 4 minus 6, I get negative 2 meters per second is your change in velocity. On some of the problems on the worksheet, it's going to say calculate the change in velocity between 10 and 30. Well, if you do that, the change in velocity would just be the top part, 4 minus 6, and it's negative 2. And it makes sense. At 10, you're going 6, but at 20, you're going 4, so you had a decrease. And another thing interesting is, it's like saying during that time, well, I won't get it, but your change in velocity was actually negative, like towards the other direction. It's kind of a weird thing to think of it that way. But anyway, okay. Now, 2.3 minus 1.0 second will be 1.3 seconds. Sorry. Now, I want you to see how the unit of this works out. So what is 2 divided by 1.3? It's kind of weird. It's going to be a fractional number. It's going to be, wait a minute. No, it's not. 1.5. Okay, sorry. 2 divided by 1.3 equals 1.5 meters per. Now watch this, the unit. Meter per second over second. Meter per second. What in the world does that mean? 1.5 meters per second every second. So the way we write it, and this is a strange thing, but your acceleration will be 1.5 meter per second squared. That's how we write acceleration. Now, whenever you see 1.5 meter per second squared, that means every second it is increasing. Well, no, I'm sorry, it's negative 1.5. Sorry, it's negative. This number should be negative because the top number is negative. Negative 1.5 meter per second squared means every second your velocity is going down by 1.5. So let's just say you started at a velocity of 10 and you stayed with that same acceleration rate, negative 1.5 meter per second squared. What that means is in 1 second, you won't be going 10 anymore. You'll be going minus 1.5. So it'll be 10, 9, 8.5. Okay? In the next second, you'll be going down again minus 1.5. If you stay at that same rate, you'll be going 7. The next second, you'll be going 5.5. So what it tells you is every second you decrease by 1.5. Now, that would be if you stay at that same acceleration rate. Okay? But now, in this problem, they didn't. You see they go up, down, up, down. Okay. All right. So really, that's all you're going to do. You're going to calculate all these on a worksheet, then you're going to analyze them. If I had put, between 0 and 20 instead of 10 and 20, if I put 0 and 20, well, then that's easy because my initial is 0 for velocity and for the time. So look at that. It'll just be 4 divided by 2.3, which is a positive velocity, and that would make sense. From 0 to 4, so during that time, even though you went up to 6 at one point, but your average velocity would be 4 divided by 2.3, which is, if you wanted to see that, 1.7, positive 1.7 meter per second squared. Okay, so, well, maybe I should just do that, just write that down, let that be the last one. So if you want to go between 0 and 20, then it would be, that's your final, is 20 and 0. Your final is 4 meter per second at 2.3 seconds. And then you started at time 0 and velocity 0. So that's just going to be 4 meter per second divided by 2.3 seconds. Now it's going to be positive 4, so it's a positive acceleration here. So 4 divided by 2.3, 1.7 meter per second squared. That's how I always want you to write the velocities, okay? And the line above it just means average acceleration. We're not going to always use that symbol, but for now, for this lesson, we will. Just so you know that technically that would mean instantaneous acceleration, and then what the other would be average. And the same way, instantaneous acceleration will be the same thing that you see. What was your acceleration in this moment? It has to be compared to something else as well. So, all right. So just work that worksheet, and then, like I said, you're gonna calculate several on this worksheet, like between say 0 and 10, 10 and 20, 20 and 40, 30 and 50. This is going to ask you to analyze one with the other and where is an increase or decrease, that kind of thing. So, all right. Well, you're going to love this chapter. You're going to really like it. It has some real practical things, neat things. I mean, if you ever get, pulled over by police or whatever. You've got some video evidence of your driving or whatever it was. Or there's a lot of stuff you'll see. There's a lot of things in this chapter to prove was that car really going that fast? We can look at the marks on the street. A car drives and it hits the skid marks on the road, and from that you can actually tell from the skid marks. You can tell how fast the car was going. You need a little bit more information as well. So you might need a little like a video. If you had a video, you'd be perfect. A video and the skid mark there. You can figure out almost anything. What was their velocity? How far did they skid? All that stuff. It's really neat. But that's just one thing. Anyway, I hope you guys will like this chapter. So I'll see you. Work that assignment. See you.